Assalamualaikum and hello everyone. Okay, so we are going to proceed to the new chapter, which is chapter 13, gas laws and kinetic energy. In this video, I'm going to explain the first one, ideal gas equations. So here we have two learning outcomes. First, you should be able to solve problems related to ideal gas equation, which is PV is equal to nRT. Second one, you should be able to discuss the following graph of an ideal gas. So we have three different graphs, PV, VT, and PT. Okay. First of all, let's look at what is ideal gas law. So ideal gas law is an ideal gas that obeys all the gas law over all pressure and temperature. So ideal gas law ni dia obey Boyle's law, Charles' law and Gay-Lussac's law ataupun we call it as Fraser's law. Okay, so before I explain each of these law, let's look at what is the ideal gas equation. Okay, so the ideal gas equation here is PV equal to nRT, di mana P adalah pressure. Here pressure must be in SI unit, which is Pascal. V is volume in SI unit, meter cubic. N is the number of mole, which is only one unit, which is mole. R here is the molar gas constant. So this one here, molar gas constant, equal to 8.31 joule per Kelvin per mole. So since this one adalah constant, you will be getting the constant given in the list of constant in exam. So tidak perlu ingat pun, tidak apa. And last one is temperature, which is in Kelvin. So the SI unit untuk temperature adalah Kelvin. Or we can also use another formula or another equation untuk ideal gas equation in terms of another constant. So dekat sini kita panggil dia sebagai molar gas constant. Now it is in terms of Boltzmann constant, which is a value for K. Di mana value for K dekat sini adalah 1.38 exponent negative 23 joule per Kelvin. Okay, so this will be the equation. PV still the same. So N dekat sini adalah berbeza. Dekat sini small n represent the number of mole. But capital N here represent the number of gas molecules. Dan K adalah Boltzmann constant, P is still the same, temperature. So here, using the first equation, we substitute R is equal to K and A. So R here, wait, let me do it here. R is equal to K and A, di mana NA dekat sini adalah Avogadro constant, which is this value. So you are familiar with this value, right? So when we substitute this one to here, kita akan dapat PV is equal to N, K and A, T. Okay, since the number of mole, we have two formula untuk number of moles. First, number of moles is equal to mass divided by molar mass. Second one, number of mole is equal to the number of molecules divided by Avogadro number. So N here, okay, kita boleh, NA here, so kita ada NA, right? NA adalah sama dengan number of gas molecules. So that's why kita akan substitute this one, PV is equal to NKT. Okay, kita akan substitute this one to here. So NA times N adalah sama dengan N, capital N. That's why kita akan dapat a new equation for ideal gas law, which is PV is equal to NKT. It's the same thing actually, benda yang sama sahaja. Okay, we either use this one or this one. It depends on the information that we are given. Okay. We can also substitute the value for N here to this equation. So kita akan dapat PV M divided by M RT, ataupun substitute this value di mana N will be equal to N divided by Na, number of molecules divided by Avogadro constant. Okay, so this one kamu tahulah macam mana mau substitute based on the information that we are given. Okay, kita akan tengok nanti dalam video example. Okay, so now kita akan tengok each of these law. So we have 3 laws here: Boyle's law, Charles' law, and Gay-Lussac's law. Okay, so since we have the ideal gas equation PV is equal to N RT, so ada 3 benda yang penting dekat sini: pressure, volume, and temperature. Since this one adalah constant, so 3 benda ni adalah sangat penting. So untuk each of these law, okay, akan ada satu quantity yang constant. So ada 2 quantity sahaja yang akan berubah. So we have P, VT, right? Okay, untuk Boyle's law, quantity yang constant adalah temperature. So apabila quantity temperature constant, this one constant, so kita boleh nampak dekat sini PV sama dengan constant all of this, right? Meaning that here P is equal to nRT divided by V. So P will be inversely proportional to V. Meaning that here when P increase, V will be decrease. So kita akan dapat the graph will be inversely proportional like this lah, P against V. Or if we want to plot the graph P against 1 over V, so kita akan dapat linear macam ni. Okay, so since all of these are constant, if we want to compare from initial value to final value, kita akan compare in terms of ratio P1 V1, di mana 1 ni maksudnya initial value, is equal to P2 V2. Okay, next one untuk Charles' law pula, yang constant adalah pressure. So the pressure will be constant. So apabila pressure constant, kat sini you can see that V is directly proportional to T. So when V increase, T will also increase. So when we plot the graph, kita akan dapat linear graph V against T untuk Kelvin. So untuk degree Celsius, kita akan dapat macam ni lah. Because usually kita tidak guna this graph. Kita akan gunakan this graph only because the SI unit for temperature is Kelvin. Okay. So when we want to find it in terms of ratio compared to initial and final volume or temperature, we will use this one. V1 over T1 is equal to V2 over T2. And then last one is Gay-Lussac's law ataupun kita panggil sebagai pressure's law, di mana the quantity that is constant is volume. So volume will be constant, this one. So when this is constant, P will be directly proportional to T. So when P increase, T will also increase. So we will get this graph of linear graph lah. So when we want to compare initial and final in terms of ratio, kita akan gunakan P1 over T1 is equal to P2 over T2. So each of these law hanya ada satu quantity sahaja yang constant dan 2 quantity yang berubah. Okay, tetapi akan ada certain condition di mana ketiga-tiga quantity akan berubah. So meaning that here PV is equal to nRT. So ketiga-tiga ni akan berubah. Maksudnya yang constant hanyalah NR sahaja. So PV over T is equal to NR, di mana NR ni adalah constant. This one is constant. So if we want to compare from initial to final situation, kita akan dapat P1V1 over T1 is equal to P2V2 over T2, di mana ni adalah initial dan ni adalah final. So kena ingat dekat sini, for each of this law, this is what we are going to use. So depends lah, usually senang je mau ingat. Okay, mana satu yang constant? So kita akan ingat the original equation, the ideal gas equation. Apa yang constant? So contohnya P adalah constant here. Maksudnya kita tinggal, benda ni semua akan jadi constant. So meaning that kita akan dapat P1V1, P2V2. So kalau volume yang constant, sorry here. So if volume yang constant, so kita akan dapat P1 over T1. Yang lain semuanya akan jadi dekat sebelah kanan. So ni adalah constant. So that's why kita akan dapat P1T1. P1T1 equal to P2T2. This one lah. So kalau what else? Tu tadi adalah V constant, right? Kalau P pula yang constant, so kita akan dapat V, this one letak di bawah. So V1T1 is equal to NR over P. So this one constant, we just biarkan saja. So akan dapat V1T1 equal to V2T2, which is this one. Okay. In question, in some of the questions, dia tidak akan bagi spesifik what is the value for pressure, what is the value for temperature. But instead, dia akan bagi tahu, okay, the gas is at standard temperature and pressure, at STP. So, kalau dekat STP, kamu kena ingat, the temperature will be equal to 273.15 Kelvin. The pressure will be in equal to 101.3 kilopascal. And the volume will be equal to 22.4 liters or 22 decimeter cubic. Usually kita akan gunakan dalam SI unit lah, this one. Okay, so kalau soalan tu bagi tahu, the gas is at standard temperature. So standard temperature, this one lah. And one more thing, if we want to convert from degree Celsius to Kelvin, because Kelvin adalah SI unit. Okay, let's say if we are given the temperature equal to 20 degrees Celsius and we want to convert to Kelvin. So untuk convert, we just simply add 273.15. So kita akan dapat 293.15 Kelvin. So conversion daripada Celsius kepada Kelvin, just tambah this value only. Okay, so kita akan tengok example in the next video. That's all for the first one here. Thank you.